Hello, my dear student. In previous video, we have discussed the military applications of laser. In this video, we have discussed the scientific applications of laser. Scientific applications of laser. In that first, that is the laser deposition. This is the scientific applications of the laser. First are the laser deposition. In that, for pulse laser deposition, that is a PLD, is a physical vapor deposition. Pulse laser deposition PLD is a physical vapor deposition, that is a PVD technique where high power pulse laser beam is focused. बघा काय, this technique where is a high power pulse laser, not a CW. CW is a continuous wave laser, and this is the pulse laser. But this pulse laser is a high power pulse laser beam is focused inside a vacuum chamber to strike the target. कशामध्ये फोकस केला? हाय पॉवर पल्स लेझर बीम दॅट फोकस इनसाइड द व्हॅक्यूम चेंबर टू स्ट्राइक द टार्गेट. टार्गेटला काय करतोय? स्ट्राइक द टार्गेट ऑफ द मटेरियल दॅट इज टू बी डिपॉझिटेड. It will be the strike of that target and that material that is to be deposited. This material is vaporized from the target. That material काय होणार? Vaporize from the target in a plasma pulp, and that target which deposited it as a thin film or on a substrate, that is such as a silicon vapor facing the target. And this process can occur in ultra high volume or in the presence of a background gas such as oxygen, which is commonly used when depositing oxides to fully oxygenated the deposited film. काय म्हटलंय? काय करतो आपण PVD technique, that the high power pulse laser beam focus inside the vacuum, and तो कशाला स्ट्राइक करतो? टार्गेटला. And material is to be deposited, and that material is vaporized from that target and which is deposited and thin film on a substrate. And this process, that process occur the ultra high vacuum or in the presence of background gas such as oxygen, and which is commonly used when depositing oxide to fully oxygenated the deposited films. Okay, while the basic setup is simple relative to many other deposition technique, the physical phenomena of laser target, of laser target interaction and film growth are quite complex. When the laser pulse is absorbed by the target, काय म्हणलंय? Many other deposition technique, the physical phenomena of this laser target interaction and film growth are quite complex. When laser pulse is absorb that target, and energy is first converted to, and that energy absorb केली target energy, laser pulse absorb target काय करतो? absorb करतो and energy convert करतो. First converted into electronic excitation and then into thermal, chemical and mechanical energy, resulting evaporation, ablation, plasma formation and even exfoliation. Okay, laser pulse काय करणार? absorb करणार ते target and energy convert करणार to electronic excitation and then into thermal, chemical and mechanical energy, resulting evaporation, ablation, plasma formation and even exfoliation. The ejected space is expand into surrounding vacuum, and that ejected spaces काय होणार? the eject केलेले spaces आहे, that will be the expand of that surrounding vacuum in the form of plume containing many energetic species including atoms, molecules, electron, ions, clusters, particular and molten globules before depositing the typically hot substrate. Okay. The detailed mechanism of PLD are very complex. The mechanism I detail PLD are very complex, including the ablation process of target material by the laser irradiation. process of the target material by the laser irradiation, the development of a plasma pulp, the development of a plasma pulp with high energetic ions, electrons as well as neutrals, and the crystalline growth of the film itself on the heated substrate. The process of PLD can be divided into 4 stages. काय म्हटलं इथे जे डेटल मॅगॅनिझम आहे PLDचं, it is a very complex, including the ablation process of the target material by the laser irradiation, the development of plasma plume with high energetic ions, electron as well as a neutral, and crystalline growth of the film itself on the heated substrate. And that process of PLD can generally divide it into process of PLD. PLD is a pulse laser deposition. Okay. The process of PLD can be divided into 4 stages. The 4 stages: first, laser absorption on the target surface and laser ablation of the target material and creation of plasma. PLDच्या प्रोसेस किती 4 स्टेजेसमध्ये. लेझर ॲब्सॉर्प्शन ऑफ द टार्गेट सरफेस, लेझरचं काय होतं ॲब्सॉर्प्शन होतं टार्गेट सरफेसवरती, अँड लेझर ॲब्लेशन ऑफ टार्गेट मटेरियल अँड क्रिएशन ऑफ प्लाझ्मा. बघा, लेझर ॲब्सॉर्ब करणार लाईट, लेझर ॲब्लेशन ऑफ द टार्गेट मटेरियल अँड क्रिएशन ऑफ प्लाझ्मा ऑफ दॅट टार्गेट मटेरियल म्हणजे इन द सरफेस. सेकंड, डायनामिक ऑफ द प्लाझ्मा. थर्ड, डिपॉझिशन ऑफ द ॲब्लेशन मटेरियल ऑन द सरफेस, डिपॉझिशन होतं ॲब्लेशन मटेरियल ऑन द सबस्ट्रेट. अँड फोर्थ, न्यूक्लिएशन अँड ग्रोथ ऑफ द फिल्म ऑन द सबस्ट्रेट सरफेस. काय होतं फोर्थ? न्यूक्लिएशन अँड ग्रोथ ऑफ फिल्म ऑन द सबस्ट्रेट सरफेस. Each this step of crucial for crystallinity, uniformity and stoichiometry and resulting film. The most used method modeling PLD process are the Monte Carlo techniques. बघा, PLDच्या 3 stages सांगितल्या. लेझर ॲब्झॉर्प्शन ऑन द टार्गेट सरफेस, the absorption, then laser ablation of that target material and creation of plasma. Second, dynamic of the plasma. Third, deposition of the ablation material on the substrate, nucleation and growth of the film on the substrate surface. Okay, these are the 4 steps of that process of that PLD, and these are the first scientific application, that is the laser deposition. Then second is a spectroscopy. Second scientific application is a spectroscopy. Spectroscopy denotes the method where interaction of light with matter. Spectroscopy denote the method where interaction of light with matter is utilized. In many cases, laser are used to light source. त्याच्या आणि मेनी केसेसमध्ये इंटरॅक्शन काय होते? स्पेक्ट्रोस्कोपी डिनोट इंटरॅक्शन होते कशाची? लाईट विथ मॅटर. बट इन मेनी केसेस लेझर यूज ॲज ए लाईट सोर्स, आणि लेझरचा यूज कशासाठी यूज केला जातो तिथे? लाईट सोर्स फॉर स्पेक्ट्रोस्कोपी, अँड विच इज देन कॉल्ड ॲज ए लेझर स्पेक्ट्रोस्कोपी. त्याच्यामुळे त्याला काय म्हणतो आपण? लेझर स्पेक्ट्रोस्कोपी, ऑर समटाइम्स इट इज ए लेझर स्पेक्ट्रोमेट्री. लेझर स्पेक्ट्रोमेट्री. देन लेझर ॲब्सॉर्प्शन स्पेक्ट्रोस्कोपी. Laser absorption spectroscopy. A frequently used method is laser absorption spectroscopy. Is frequently used केली जाते मेथड कोणती? लेझर ॲब्सॉर्प्शन स्पेक्ट्रोस्कोपी, वेअर द ट्युनेबल नॅरो लाईन विथ लेझर. ट्युनेबिलिटीचं मिनिंग तुम्हाला प्रिव्हियस सांगितलंय. एका लेझरच्या टाईपमध्ये आपण घेतलंय, दॅट इज अ ट्युनेबल लेझर. That is the tunable laser. That means जो आपला ऑप्टिकल रेझोनेटर असतो. What is mean by optical resonator? Optical resonator which have a 2 mirrors. One is a fully reflected, other is a partially reflected. Partially reflected means 10% reflected, 10% transmitted and 90% reflected. That is the optical resonator. It is one of the component of that some lasers. That is HED laser, ruby laser, okay, carbon dioxide laser, dye laser, semiconductor लेझर. ओके, बट दॅट इज अ ट्युनेबल लेझरमध्ये काय करतो आपण की एक मिरर काय करतो? रिप्लेस करतो. कशाने? डायफ्रॅक्शन ग्रेटिंगने. कशाने रिप्लेस करतो? डायफ्रॅक्शन ग्रेटिंगने. अँड दॅट इज द ट्युनेबिलिटी. आणि मग ते प्रोसेस काय होते? रिफ्लेक्टेड बॅक द डायफ्रॅक्शन ग्रेटिंग वॉज आपण काय करतो? मूव्ह करतो. दॅट अँगल विल बी चेंज, अँड दॅट इज द ट्युनेबल लेझर. आपण प्रिव्हियस व्हिडिओमध्ये बघितलंय, एक टाईप बघितलाय आपण तिथे. ओके, A frequently used method is a laser absorption spectroscopy where the tunable narrow line with laser, that is a frequently single frequency laser, is tuned with some wavelength range. And tunable laser मध्ये काय होतं, that will wavelength will be also changed, that is 2d theta is equal to 2d sin theta is equal to n lambda. The equation पण आपण बघितलंय तिचं. Okay. This tunable narrow line with laser is tuned through some wavelength range and the light absorption in some sample, that is a reduction of optical power of probe beam, is measured as a function of that wavelength. काय म्हटलंय, laser absorption spectroscopy. Some frequently used method is a laser absorption spectroscopy where the tunable narrow line width is tuned through some wavelength. But tunable narrow line with laser काय होतो, tune होतो some wavelength range and the light absorption in some sample is measured as a function of wavelength. Obviously, the spectral resolution is limited by the laser line width. Spectral resolution is limited by the laser line width, which is therefore often minimized with suitable laser design. Then minimize करू शकतो आपण laserच्या suitable design. Extremely high precision is required and achieved in the area of optical frequency metrology. Extremely high precision is required. High precision laser will be required and achieve the area of optical frequency metrology. For example, for realizing the extremely precise optical clock. Extremely precise optical clocks. Okay, these are the example. Then absorption feature are not always directly investigated by measuring wavelength and dependent absorption. These absorption features are not always directly investigated केले होते by measuring wavelength and dependent absorption. Instead, one may exploit more subtle effects or modulated laser beam. Modulated laser beam, that is a frequency modulation spectroscopy, or detect sound wave included by laser pulse. काय म्हणलंय की absorption feature are not always directly investigated by the measuring wavelength and dependent absorption. Instead, one may exploit more subtle effect on modulated laser beam, that is a frequency modulation spectroscopy, or detect sound wave included by laser pulse. And the last is a third scientific application is optical fiber communication. And these are the last point of that course, of module number 4 and the course of that laser fundamental and its application. In this lecture, we have completed the course second, that is a laser fundamental and its application. Then optical fiber communication, third scientific application of laser. Laser communication system are used to transfer. Laser communication system are to transfer information from one point to a distant point. Okay? Optical fiber communication application बघतो आपण, scientific application. That is the laser communication system is used. काय communication system used to transfer. काय transfer करायचं? Information from one point to distant point. The information may be is audio conversion or a stream of data of one computer to another or several simultaneous television broadcast. The distance may range from a few feet to thousands of miles. काय म्हटलंय? डिस्टंट पॉइंट पर्यंत आपण इन्फॉर्मेशन ट्रान्सफर करू शकतो. कशाने? द लेझर कम्युनिकेशन. मग इन्फॉर्मेशन कशी कोणती पाठवणार? द इन्फॉर्मेशन मे बी अँड ऑडिओ कन्व्हर्जन. ऑडिओ कन्व्हर्जन सुद्धा काय करू शकतो आपण? सेंड करू शकतो, ट्रान्सफर करू शकतो. Or stream of data from one computer to another, or several simultaneous television broadcast. The distance may range from, among the distance किती असो, from few feet to thousands of miles. These are used in that laser communication or that fiber, and this is known आपण त्याला म्हणतो आपण optical fiber communication. Optical communication system is the past consisted of techniques such as a fire signal, smoke signal, flash lanterns, reflected sunlight and signal flag. Such system had limited bandwidth and were not competitive with electronic communication like radio. Optical communication system is the past consisted of technique. Some techniques तुम्हाला सांगितलेले आहे. The invention of laser provided the coherent optical source capable for transmitting information at extremely high data rates. The invention of this laser provide a coherent optical source capable of transmitting information at extremely high data rates. However, the limitations of transmission of light through the atmosphere, such as a turbulence, haze, fog, absorption, and rain, limited the usefulness of laser for transmission of information through the atmosphere. काय म्हणले? The invention of this laser provide a coherent optical source capable of transmitting information of extremely high data rates. However, the limitation of transmission of light through atmosphere. मग आता through atmosphere आलं म्हणजे काय येणार आहे? That fog, absorption, and rain. Limited and usefulness of laser transmission of information through the atmosphere. The modern optical communication system are used semiconductor laser or transmit light through optical fiber. Such systems have become widely used for telecommunication. And this modern optical communication system use semiconductor laser. काय यूज करतो? Semiconductor laser that transmit light through optical fiber. Such system have become widely used for the telecommunication. Okay, these are completed the module number 4 and the course laser fundamental and its applications.